This is a modified problem from the physics books by Resnick and Halliday. A person standing on top of ellipsoid rock kicks a ball initially at rest to give it a horizontal velocity v. The cross section of the rock in the direction of the kick is an ellipse with a semi-major axis equal to a and semi-minor axis is equal to b. What must be the minimum speed v if the ball is never to hit the rock again? So what they are saying is you have to kick the ball in such a way, you have to kick a ball horizontally in such a way that it never hits the rock again and falls off the rock onto the ground. With this speed, how far does the ball fall from the center of the rock? If the person stands on the hemispherical rock of radius r, what must be the minimum speed and how far will the ball land? So the second part of the question is simply what happens in a special case if this ellipse is a hemisphere of radius r. So to solve this problem, first we have to realize that the path of the ball is going to be a parabola, and this rock is already in shape of ellipse, right? So we have to find out how can that parabola be lying on the shape of this ellipse. So you can refer to this figure over here. So the red curve is actually the surface of the ellipsoid, and the blue solid line is the path of the ball. The blue dotted line is just to complete the shape of the parabola. So we have to find what must be the equation of this parabola so that it touches the ellipse only tangentially at this vertex at one point, at this point 0 comma b, right? So I'm assuming that our axis is over, so this is our origin and this is our x-axis and this is our y-axis, right? So given these conditions, first we have to find out what must be the equation of motion, what must be the equation of this parabola for the football, right? So we know that the motion of equation in the vertical direction for the football is going to be b minus the initial speed in the vertical direction is 0 because the ball has been kicked horizontally, and the acceleration due to gravity is negative g. So if you use ut plus half at square, you get b, which is the initial distance from where it is being thrown, minus initial speed is 0, so that term turns out to be 0, minus half acceleration is g t square. We are using minus because g is acting in the negative y direction. So b minus half gt square is the equation of motion for the football in the vertical direction. What is the equation of motion for the ball in the horizontal direction? It is going to be simply x is equal to the speed in the horizontal direction, which is v, times t. Now from this equation we get t is equal to x over v, and I substitute this x over v in this equation, so you get y is equal to b minus half g x by v square, right, which is going to be b minus g by 2v square times x square, which again I can write as b minus k x square, where k is g divided by 2v square. So you can see that y is equal to b minus kx square is going to be the equation of a parabola, right? If you plot it on a graph paper, you can see that it is going to be the equation of a parabola. Now what about the equation of the red curve, the ellipse? The equation of the ellipse is going to be, we know that the equation of ellipse is equation of ellipse is x square by a square plus y square by b square is equal to 1. So what is y square from here? You get y square is equal to b square times 1 minus x square by a square, which is going to be b square minus b square by a square x square, right? So we have y square is equal to b square minus b square a square x square, and y is equal to b minus k x square. So how to find where would these points be intersecting? Simply equate both the y's. So from here we have y square is equal to, that is from the parabola equation we get y square is equal to b minus kx square, and the square of that is equal to, from the ellipse we have b square minus b square by a square x square. So if we expand the parabola, you get b square plus k square x to the power 4 minus 2b k x square. This should be equal to b square minus b square by a square x square, and we can see that this b square and this b square cancels out, and now we have to simply solve for what is x going to be. So you have k square x to the power 4, this is going to be equal to, I bring this minus 2bk x square this side, so you have 2bk minus b square by a square, and this entire thing by times x square. So we can divide x square from both the sides, so this cancels out, and over here you are left with k square x square. So you can solve for x square as it should be equal to 1 by k square 1 by k square times 2bk minus b square by a square, right? So we know what our x square should be equal to. It should be equal to 1 by k square times 2bk minus b square by a square. But we already know that this x happens to be 0 at the intersection point, right? Or other way of thinking would be, if I am to solve this equation where x square is equal to something which gives me only one root, so right, I'm saying that, just think about it. I'll use a different color so that you can see that this is not. If I say that x square is equal to m, and I'm saying that x intersects at only one place, there can be only one possible value for x, what should be m? It can only be 0, because only x square is equal to 0 gives us only one value, right? Because x square is equal to 0 gives us only one value, which is x is equal to 0. If x square were 4, you would get two values, which is plus 2 and minus 2, right? So I know that this has to intersect at only one point, and that one point has to be given by x is equal to 0. So I know that this entire thing should be 0, right? This entire thing that I put in a box should be 0. So if this entire thing is equal to 0, I know that it can be 0 only if 2bk minus b square by a square is equal to 0. So this implies that 2 times bk minus b square by a square should be equal to 0. B can be taken out common, so you get 2k should be equal to b by a square, right? And therefore you get that k should be equal to b by 2a square. But what was k initially? K was actually g by 2v square. So b by 2a square should be equal to g by 2v square. And from here we can solve for v, right? So now we are on the final step, so I don't want to go to the new page. I'll just do it somewhere over here. Just find some space. Maybe I'll just use this space over here. So we know that v square should be equal to g by a square times g by b, or v should be equal to a divided by root b times g. And we are done. So this should be the minimum speed with which you should kick the ball. Now suppose this is not a ellipsoid but a hemisphere, right? So I'm talking about the second part of the question. Second part of the question is that it's a hemisphere. So in that case, both my minor axes and my major axes are going to be equal to the radius of the hemisphere, and you will get v is equal to r divided by root r is going to be square root of r, and this is also in square root. This is also in square root because it is g here. So you get square root of g times r. So this is what our first part of the problem is, that what should be the minimum speed of the ball if it's an ellipsoid. In that case it is a times root g divided by root b, and if it is hemisphere it's going to be simply v is equal to root times g times r. Now let us come to the second part of the question, which is asking how far does the ball fall from the base center of the rock. So we know what should be this distance. This distance is where the parabola y becomes 0, that is b minus kx square should be equal to 0. So we know that this will happen when my equation of ellipse, which is my equation of parabola, which is b minus kx square, turns out to be 0, or my x square happens to be b divided by k, and x happens to be square root of b by k. But we already know that what is k? K is simply g divided by 2v square, right? So we put this value over here, or we can actually look at what is going to be b by k, right? We can also find out what is going to be b by k from this equation over here, right? b by k is actually equal to 2a square, right? You know that 2k is equal to b by a square. So b by k, so I'm actually referring to this equation over here, this one, right? So I know that b by k is equal to 2a square. So what is square root b by k? So this implies that x is equal to square root of b by k, which is going to be root 2 times a. So this is the range if it's an ellipsoid. If it's a hemisphere, then a is equal to b is equal to r, and you will get x is equal to square root 2 times r, and we are done.